All right, so we have the length of a rectangle is represented by the cube root of 81, and the width is represented by the cube root of 3x to the 9th, and we want to determine an expression for the area of the rectangle. Okay, so we know that the area of a rectangle is length times width, and if the length is the cube root of 81, and the width is the cube root of 3x to the 9th. Let's see, 81, isn't that 3 to the 4th? Yeah, it would be. Okay, so let's do this. If we take a look here, this is 3 to the 4th power, but this is 3. So I have 3 to the 4th is 81 times 3 times x to the 9th, and that's really the cube root of 3 to the 5th times x cubed. Now a lot of times we have numbers here, so a lot of times you'll see me, I'll be like, oh, this is 27 times 3 and 27 is a perfect cube. But if we rewrite a number to a power, then we're going to do the same thing we would do as if we have a variable to a power. So now I'm treating 3 like a variable, and I have this 5 and the 3. So I'm going to rewrite this as the cube root, and I have 5 3's here, but I only need to have 3 of them to pull out. So this is the same thing as 3 cubed times 3 squared. So think x squared times x cubed is x to the 5th. I'm just using 3 for my base. And then this was, oh, it looks like I changed this 9 to a 3. Let me change that back. This is 9. This is 9. Okay, and then I have x to the 9th. The cube root of 3 is 3. The cube root of 3 squared I can't change. Cube root of x to the 9th, 9 divided by 3 is x cubed. And then don't forget, a lot of people keep forgetting to write this 3 in this radical sign. You actually do have to write that. It is an incorrect answer. The square root of 3 or 9 is not the same thing as the cube root of that. Now, I took the cube root of these. 3 squared is 9. That's what's left over. Now, if I'm trying to find the perimeter of the rectangle, okay, the perimeter is 2 times the length plus 2 times the width. So I'm adding up the 2 lengths and I'm adding up the 2 widths, okay? So that's going to equal twice the cube root of 81 plus twice the cube root of 3x to the 9th. All right. So if we simplify, this would be twice the cube root. 81 is 27 times 3 plus twice. I can go ahead and take the cube root of x to the 9th. That's going to be x cubed. And then the cube root of 3 is left over. And 27, the cube root of 27 is 3. So this becomes 2 times 3 times the cube root of 3 plus 2x cubed times the cube root of 3. And that equals 6 cube root of 3 plus 2x cubed cube root of 3. Now, these are like terms, the cube roots of 3, but this x cubed cannot be added to the 6, so we would have to leave this as is. Okay, so even though the roots are the same, because there's an extra x cubed here, we're unable to add these two terms. They are not like terms. For 7, they give you the area, and they tell you the length, and they want you to find the width. So if the area is length times width, and we want to solve for width, then the width is just the area divided by the length. So the area of this is 54 m to the 7th n to the 5th The length is the cube root of 27 m cubed n to the 8th. So for this, it's kind of up to you how you want to do it. We can certainly simplify first. So if I put this all underneath one cube root, let's take a look at what happens here. 54 divided by 27 is 2, and that's going to go on top. I have 7 m's on top and 3 m's on bottom, so that's going to give me m to the 4th on top. I have 5 n's on top, 8 on bottom, so that's n to the 3rd on the bottom. All right, so if I want to take the cube root, the 2 I can't change. The m, see how m is to the 4th, right? I have 3 m's in there, but I have an extra one, so that's m cubed times m over n cubed. Okay, so let's go ahead and evaluate now. The 2 stays, m cubed comes out, the m stays, n cubed also comes out, and so I'm left with the cube root of 2m on the inside. Okay. Number 8. All right. For a parallelogram, the area is the base times height. So they give you this. Here's our base, and here's our height. So we're really just multiplying the square root of 6x to the 5th times 2 square root 12x to the 4th. The 2 we can't multiply, well, we can multiply it by 1 here, but the 2 is going to stay in front, and I'm going to combine everything in this square root. 6 times 12 is 72. X to the 5th, x to the 4th is x to the 9th. And so then we're left with a 2 square root. 72 is 36 times 2. X to the 9th. Now I'm trying to take the square root, so that means I need to divide the exponent by 2. So that's going to be x to the 8th times x. And now I can evaluate here. I have the 2 still. The square root of 36 is 6. The square root of x to the 8th is x to the 4th. And then I'm still left with the root 2x. So this is 12x to the 4th root 2x. The triangle is just 1/2 base times height. So I get 1/2. Here's my base. Here's my height. So 1/2 root AB to the 7th times the square root of 10a to the 4th b to the 0. So then let's simplify this. I can multiply the roots together. 8 times 10 is 80. A to the 1st, a to the 4th is a to the 5th. B to the 7th, b to the 0 is just b to the 7th. And let's see, 80, is that 16 times 5, maybe? It is, okay. So we get 1/2, the square root of 16 times 5. Because I'm taking the square root, I'm going to try to rewrite a and b so that their exponents can be divisible by 2. So this is going to be a to the 4th times a, so there's 5 a's, and b to the 6th times b is 7 b's. And now I can go ahead and evaluate. I get 1/2, square root of 16 is 4. Can't do anything with 5. A to the 4th squared is a squared. Can't do anything with the a. B to the 6th, the square root of that is b cubed, because 6 divided by 2 is 3. And then can't do anything with the b, and that becomes 5ab on the inside. So the final area is 1/2 of 4 is 2. A squared b cubed root 5ab. And last problem for number 9. We want to write an expression for a times b, so we're just multiplying these two. So for this one, we have 36 times 5, but 36 is a perfect square. So I'm going to go ahead and not combine those together. So let's do this. A times b, I'm going to do it this way, equals, I'm going to combine them underneath one root. I'm going to keep the 36 times 5. So I'm not going to actually multiply this because I already know 36 is a perfect square. Now I have a to the 4th and I have a. Now I'm going to be taking the square root of these, so I want to leave my a's as an even number if possible. So I'm going to leave this as a to the 4th times a. But b to the 7th times b, b to the 7th, there's 7 b's and one more b. I'm going to go ahead and combine that as b to the 8th so that I have an even exponent on b. The square root of 36 is 6. Square root of a to the 4th is a squared. Square root of b to the 8th is b to the 4th. So remember, we're just dividing those exponents by 2. And then I had the square root of 5a left over.